Hi, let's get started with the presentation here. So I want to first thank you all for coming out tonight to final presentation night. It's the most rewarding night of the year for all of us here in ISM, and I know that we all love to share what we've been working on this year. Me especially, this being my second year. I know a lot of you were here last year. Thank you for your continued support. I did something similar this year, but different. So it'll be an interesting talk tonight about just kind of what I've been doing this year and what I've learned. So, like I said, most of you were here last year, but for those of you who weren't or who need a refresher, I'd like to start with what is mechanical engineering? And more importantly, maybe, what is it to me? So in general, mechanical engineering is the study and application of material science, math, various different disciplines of structural and theoretical knowledge that allows engineers to apply science to real-world systems and physical things. So pretty much anything around you is in some way created by a mechanical engineer. From the chairs you're sitting in, the structural design of it, the load capacity and everything was considered by a mechanical engineer. The desks here in this classroom were all somehow, down to the component level, involved, there was mechanical engineering involved. So it's an extremely broad topic. In some schools, some universities, it includes 37 different subspecialties. So over the past few years, I've had the opportunity to kind of explore the field, learn more about what I like. But I think what's important to me is my foundation, my interest, the root of my interest in the field. So in order to understand my interest in engineering and what mechanical engineering means to me, you have to understand some of the things that I've done in the past. So my past experiences, I like to tell it as a narrative of cars. It starts back all the way back with Pinewood Derby through my church group in elementary school. And if you're not familiar with the Pinewood Derby, basically it's racing little blocks of wood. Mine never raced very fast, but they always looked really good. It's kind of a consistent theme throughout my projects. They look really good. They might not always go very fast. But that was where it all started, with the Pinewood Derby cars. Some of my favorite projects included the Yellow Submarine. It was literally a little yellow submarine, but it had a voice box inside that would play the Beatles' classic song, "We All Live in a Yellow Submarine." I also had the Eleanor, shout out Ellie, but it was designed just like the Mustang and gone in 60 seconds. That was another favorite. I had some great cars over the years, and that's kind of where my interest started. Now, after that, it kind of grew in size and expense. So 8th grade science fair, I designed and built a fully homemade and fully functional go-kart. Now, it ran on 3 different fuel sources. It would run on biodiesel, diesel, and gasoline. Now, it actually had 2 different motors, and I had to engineer the geometry of it all and the ways that they would swap out, because the gasoline engine's about this big, the diesel engine's about this big. So that was kind of my first real exposure to actual technical engineering problems. And that was a lot of fun. So that was in 8th grade. Coming into high school, I knew that I wanted to be a part of the ISM program. I knew that it was something that I wanted to do actually all the way back in elementary school. Miss George, my elementary school GT teacher, had told us about the program all those years ago and had encouraged us all to consider putting it in our course plans and thinking about what we might want to do in ISM. She told us about the kid who'd built a roller coaster in his backyard, and the girl who had arranged for a girl to fly from Africa and get a heart transplant. So they're very lofty goals for all of us when we heard about ISM, and I knew that that was something I wanted to be a part of. So last year, coming into the year, I had an idea of what I wanted to do for my project. I had decided that I would construct a fully electric, fully street legal vehicle. If you were here last year, you probably saw it in the rotunda, so you know that this plan came to fruition, and it was a lot of fun. It was an excellent learning experience. So my learning really started last year in ISM 1 and has continued through to this year. Last year, I interviewed mainly professors So I met with Dr. Grenade from the UTD, who is the head of research there. I met with Dr. Beshkok from SMU. He's the head of mechanical engineering. Met with Dr. Raja Shakara. He specializes in electrical vehicles and systems, actually airplanes. He worked for Rolls-Royce and their engine division. But they were all professors. I met with all these professors. And my mentor last year ended up being Dr. Grenade. He was an amazing man. Like I said, he was the head of research at UTD. So he was a professor of material science and electrical engineering, two very technical fields. And he was extremely knowledgeable in each of them. He also taught freshman chemistry just because he loved teaching. And he loved the students. He loved to get to know them freshman year, and he could really impact them. And he did his own research projects. So he specialized in nuclear radiation and analyzing that. So in addition to all those individual duties, he was also the head of research at UTD, so he oversaw all of the projects that they're working on there. It's more than a $100 million research budget. So at that point, having worked with him, I knew that research was something I would probably want to do in college because I've been exposed to so many different things through him. But I was also able to use his broad knowledge to help me with this electric car project. Now, I will say I built it entirely myself. My dad held a work light sometimes, and he paid for it all, but I was the only one who ever turned a wrench. Dr. Grenade never actually even saw the thing. He still hasn't to this day. Various scheduling conflicts have kept him from attending any of our events, which is unfortunate, but I love him. He's a great guy. I've actually continued to work with him this year. So coming into this year, I had an open mind. Having completed such a big project last year, having such a great mentorship experience, I wasn't exactly sure what I was going to do this year. Like I said, I had an open mind. So coming into this year, I first interviewed with Miss Kyra Ewer. Now, she was a family friend who works at Raytheon, and through her, she hooked me up with a couple of different Raytheon engineers. I talked to Mr. Joe Colangelo, who actually works in like their forensic problem-solving lab. So they have this lab where not just Raytheon parts, but they have contracts with other companies where they'll send their parts to him, and he'll take them apart and analyze them on the molecular level. So he's got electron scanning microscopes and big X-ray machines, and he solves problems on the cell-by-cell level. He figures out where things went wrong and helps make recommendations for how things could be better engineered. And that was a very fascinating thing to see there at Raytheon. Raytheon has a massive facility in McKinney that I think we don't really realize is there, but it's something like 4,000 employees, many of which are working in actual production of, they do optic systems there, so mainly for the military. If you've ever seen a drone, they've got a big optical guidance system on the front of the drone, and they make those there. So I got to see them working on those too. I talked to Mr. Joe Rotacco, who specializes in improving manufacturing systems. So his background was actually in business, but most of the work he does now is with engineering and interfaces with engineers. So I had a tour of the facility with him and got to learn a lot about his work, which is basically how can they streamline the process, introduce new technologies, new methods that will allow them to be more efficient, more cost efficient, and make more units for the military and make more profits for Raytheon. So he was very fascinating. That was very cool. And then I also talked to Mr. Bob Smith in the environmental testing lab. So in the environmental test facility, they have these massive machines that can replicate almost any environment found on Earth. So anywhere from high pressure, high altitude situations to hot or even cold. They can create snow inside these machines. They can create intense heat, hotter than anything you'll find on Earth. And they can create clouds, they can create rain. It's crazy. Anything you can find on Earth, they can recreate in this box. And every Raytheon product is tested in that environment to make sure that it will perform for the U.S. military when it comes time. So I got to see, he has about 100 machines, 100 things as big as this room, where they can plug parts into and see how they work. And they're actually functional while they're being tested. So there was a guy with a joystick and a monitor, and you could see the little optical thing spinning around, and you could see what it looks like when you're flying a drone. That was very cool. But all these people that I talked to at Raytheon were fascinating. They were kind of different from what I had experienced the year before. Like I said, the year before I'd interviewed all professors who were very fascinating, very knowledgeable, but the people at Raytheon were hands-on engineers. They were practicing the trade. They were constantly developing new methods and technologies and applying the engineering education that everyone I talked to had received. So that was a very fascinating kind of flip side to things. So early in the year, I was looking for something that I might do differently. And I started to do research on new technologies and things that may be applicable, somewhat related to what I had worked on the year before. I did a lot of research into electric vehicles, autonomous vehicles, and solar energy, alternative transportation, alternative energy, things like that. For whatever reason, I ended up studying a lot of what Elon Musk is doing with all of his various companies, from Tesla to Solar City to the Hyperloop, which isn't exactly his company, but it's his idea, and now the tunnels thing. So kind of, I guess, if you want to study the future of energy and transportation, he comes across your screen a lot. And so I wrote a number of research papers about work being done at those companies, and I learned a lot about kind of the way that things are going and what people are doing, and that was fascinating. So I kind of verified that my interest was still in electric vehicles and things like that. So I started looking at what could I do to continue my experience. Now, at the same time, I was looking for a home for my electric vehicle. When I started the project way back almost 2 years ago now, I knew that I wanted to eventually donate it to a school or an after-school program, a community organization, something like that, so that it could be used by probably lower-income, disadvantaged students to have similar experiences to what I had. Now, the learning that I had was priceless, and a lot of that came from my mentor, and no one can ever replicate that experience, but the hands-on experience with the vehicle itself was phenomenal, incredible. I wanted to share that experience. So from the beginning, that had kind of been in the back of my mind. What can I do to make that happen? And this year I really started to pursue that. So as I was conducting my interviews and talking to people at different events and things, I would tell them that I was looking for something like that. I was looking for a partner in this educational program, someone that I could donate the car to, someone that I could trust, that would use it for good to benefit students in the way that I imagined for years to come. So at first, I was thinking I'd donate it to a school. Different teachers, counselors had offered me contacts in administration at other schools, and so I was beginning to look into that. But then one of my early interviews was with a former NASA engineer. He had come to one of our ISM events, and I'd seen his contact information on a printout of thank you notes. And when I saw what he had done, I thought, I have to talk to this guy. So I actually called him, and I talked to him, and his name was Joe Smith, and he was fascinating. He had so much knowledge, so much experience in the field. But when I told him about my electric vehicle and how I wanted to donate it, he was able to connect me with the people that I needed. So he serves on the Boy Scouts STEM Advisory Commission in Dallas, and it's a group of people related to STEM and STEM education who hope to assist the Boy Scouts in providing those experiences for their members. So he thought at first that the Boy Scouts might be interested in taking responsibility for the car and the program. He told me that they had been looking for a big project. They'd even talked about doing an electric car, but they weren't sure where they would find all the components for that. I told him, am I the man for you? I've got just what you're looking for. So he started talking to his people on the Boy Scout Council, and unfortunately they were not as interested as we had expected. It's a very daunting project. It takes a lot of resources, time, commitment. But there was a man on his council with him, a fellow board member who's actually here with us tonight, Dr. Barry. And Dr. Berry works at the Caruth Institute for Engineering Education at Southern Methodist University. So his whole job is helping to provide exposure to STEM and STEM education for students in the Dallas area, from minorities to disadvantaged groups, women, hoping to further the mission of SMU Engineering to provide engineering education to a diverse group of people. SMU does a great job of filling their program with women and minorities far beyond the national rates, but they continue to invest in the community in order to, help in general. This is a field that needs representation from all of the population. It's something that they've struggled with in the past. So his whole job is that kind of outreach and education. So when he heard that the Boy Scouts weren't really interested, he thought maybe he could do something with it. So he gave me a call, actually sent me an email, and I called him, and we started to talk, and I immediately decided this is the guy. I trust him. I know that what he's doing is helping people, and I know that if I were to give him my car, it'll help people for years to come. I know that he'll be able to use it exactly as I intended. So I started work with him. I first met with him back in probably January and asked him to be my mentor for the year. And our goal, basically setting out, was to craft a program in a way, craft the donation of my car, gather all the information in a way that would allow him to be successful with the car in the future. So my main goal this year was to create one central source of information for him that can be used in future years when I'm gone, that would contain all of the knowledge that I gained, all of the hands-on experience with this project that might not be in an instruction manual. So basically the idea was that each year students would take apart the car and put it back together. At the end, they'd be able to drive around, experience that thrill of driving something that they built themselves, the thrill that I came to know so well last year. So I wanted to design a manual that not only had instructions for how to put together, but also take it apart. When I got the project last year, there were no disassembly instructions, and I thought it would be important to have specific instructions, because the assembly instructions are really helpful. They tell you, what tools you need, what parts you'll need, and I wanted to have the reverse of that so that students would be able to quickly and easily, in the time frame of a summer camp, be able to figure out what parts they needed, what tools they needed, and where those parts should be stored. So I've designed like a storage system, way for them to all be cataloged and everything. There's a full parts list, everything's categorized. It's very efficient. But my main deliverable is this booklet, and it's got, like I said, the forward instructions, the disassembly instructions, but it's also got some research that I did throughout the year as it relates to this vehicle. So I studied the batteries in this car, kind of looking at what do we have right now and what's available, and is the current solution the best solution for this problem? And basically what I found is yes, these batteries are the best. Unfortunately, there is a caveat to that. I've had a lot of battery problems this year. Something happened either in the atmosphere of my garage or in the way that wires came into contact in the process of building it, taking apart, where 11 of my 12 batteries have gone dead. So that was something that we've been working on this year and figuring out how we can solve that, what we can do about that. And fortunately, it looks like we're going to end up replacing all the batteries. So that's been a lot of fun. But I did a full paper on that and found that even if they do need to be replaced, they should be replaced with something similar, because it really is the best solution. I also did a study on the motor. This motor was not actually, this car was not designed for this motor. This car was designed for a motor much smaller, about half the size, half the power of this motor. But I already had this motor because I was working on a different electric car project. I was actually converting an old Porsche from regular gas to electric. And when I started this project, I decided to shift my resources to this, so I used those parts that I already had. And we were able to redesign, rework this vehicle a little bit so that it could accommodate this motor. But I did a research paper on how much more powerful is it? Is that problematic? And bigger than that, there's the debate between DC and AC power. That's the actual type of motor, the type of controller, everything. So I looked into all those things. I looked into what the car has. I looked into what it could have and whether or not this was the best solution. And ultimately, I found that the specific motor that I have, the specific brand, the specific size, is kind of the industry standard for vehicles that perform well and are fairly efficient at a decent price. So I decided that it would be best to stick with that. Now there is the possibility of switching to AC power, which would allow for the use of regenerative braking, but that is very involved, very expensive. A new AC motor, AC controller, all that would cost anywhere from $6,000 to $10,000. So ultimately, my paper determined that the current solution is perfect. I also studied the chassis. Right now, the chassis is made of a very heavy, very strong metal that is very thick, and unfortunately has rusted this year. That was another big thing I did, knocking all the rust off the vehicle and respraying it. I had decided last year to skip that step because the painting process can be, as I found, 3 or 4 weeks long, maybe even more. I was probably wise to skip it last year because I just didn't have that kind of time in my build schedule, but it definitely did have repercussions, which, I've learned something about engineering processes and taking your time to do things right the first time. That's been a learning this year. But I researched this chassis, and I researched how could it be improved, what could be done differently, because it is very heavy right now, and I'm not sure how safe it is. It's just a big old battery. It might be safe for everyone in the car, but everyone not in the car would not fare well in an accident. This car doesn't have airbags, so I kind of was looking at how could I make it safer, more efficient, lighter, everything that you want from your car chassis. So I researched how is a chassis designed and constructed. I learned that basically a chassis starts with the suspension, or the wheels really. You've got your 4 wheels, you've got your 4 suspension points, or on this car your 3 because it's a 3-wheel car. And you start from those points and you design around that. So you design structural members that will support all of that suspension. And I learned that it's a very involved process, from the design to the testing, the building of the different materials, the way that they're joined, the way it actually functions in your car. You have to do a lot of tests with big equipment, like the flex of the whole entire frame. So you have to put the whole frame on a jig and flex it and see how what its structural rigidity is like. So I learned it's very involved, but I also learned that you have different options. Things you can do to improve the design, from triangulation to a monocoque chassis, and then there's also options in materials. Like I said, it's a very thick iron or steel right now. You can recreate it with aluminum. Now that's not very strong, not very safe. Maybe that's okay for racing where you've got a lot of safety equipment, but it's probably not practical for a street legal vehicle like this. There's also carbon fiber, which is, we all know, is very light. It's being used in the high-end supercars and things like that, often in monocoque chassis where it's one big piece, no frame, tubes, or anything like that. Like I said, supercars, which have super prices, millions of dollars, and that's not just a markup. These materials and processes are very expensive, very difficult. So I learned carbon fiber probably wasn't a great option either. Ultimately, like the batteries in the motor, I found that incumbency advantage, what we have right now, is actually working pretty well, serves the purposes of this vehicle, and to change it would be very, very difficult. Now, it could be a whole project in itself, something that could be done down the road, and I've kind of done some foundational research for that, but for now, it should probably stay the way it is. So after doing all this research and learning all these things, I started to look at the actual logistics of donating the car and getting it into the hands of SMU. Now, donating it isn't too difficult. They're a university. They love to take people's money and donations and things like that. They have processes for that. But they're not typically, these donations don't typically come in the form of vehicles, especially not home-built vehicles with questionable value. So we started to look at how would this actually happen. It's not as simple as it sounds. So we looked at the registration process. SMU wanted to insure the vehicle if they're going to let students drive it, if they're going to have it on campus. In order to do that, you have to get it inspected and registered. Now, the inspection of something that is home built is not particularly easy. We actually did the research and found that it was about a 14 or 18 step process. Ultimately, I talked to Dr. Berry and we decided, let's go ahead and get it donated just as a unit. And then they could start to look at how they would actually get it insured and registered and all that within the university. They've got people for that. So my focus turned to just getting it donated. So I had to collect all of the invoices and everything, and the manufacturer's certificate of origin, which I didn't get last year. I had to go back and get it this year from the kit manufacturer. And I gave that all to Dr. Berry, and we were able to get the donation completed. So SMU is now the proud owner of a Tom Klein original electric vehicle. So that was kind of the completion of my biggest goal for the year, was to actually donate the car. Now the car will be used in the future, along with my booklet, for summer camps. Dr. Berry is putting on something like 42 different summer camps this year for young students of various ages, both residential programs, non-residential programs, mainly students from the Dallas area. Many of them disadvantaged, many of them young girls who are being exposed to STEM education for the first time. And right now they work with quadcopters and 3D printing, new and emerging technologies. And this project will allow them exposure to electric vehicles, alternative energy, all the things that I've researched over the past few years. And I think that'll be very exciting and very educational for them. Now, like I said, I really trust that Dr. Berry is going to do great work with this vehicle. And I'm really appreciative of him for helping me realize my goal of donating the car. It's very satisfying knowing that students will have experiences similar to the one that I had. Probably not quite as good, because I feel like I had a nearly perfect experience between my mentor and my experience and this whole ISM journey. But I hope that they'll be able to learn from my project as well. So that's kind of the plan for the future for the car. My plans for the future: next year I'll be attending UT Austin. I was admitted to the Honors Engineering program. I received a full tuition scholarship. And I think that that's largely the result of all of the learning experience that I had here in ISM. It's an incredible program that offers experiences unlike anything else here in Frisco. I'm very appreciative to everyone that's helped me along the way, from my parents for supporting me in this, to Dr. Grenade last year, Dr. Berry this year. I've learned so much from them and really appreciate them. To Mr. Weissong for not only giving me the opportunity to be a part of the ISM program, but supporting me throughout this whole process. When I told him I wanted to build a car, he said, go for it. I've since learned that he didn't think it would actually happen, but he wanted to support me anyways. Thank you for that. I appreciate that. But the feeling of support has always been there from him, and I really appreciate that after 2 years. I think I've learned so much from Mr. Weissong. I really appreciate him. So he's not in the room tonight, but I wanted to thank him. It's been a great experience, like I said, and if any of you in the audience, I know there's some younger people here, if you're considering ISM, I absolutely recommend it. Put it on your course schedule, figure out how it's going to work. Now, Mr. Weissong won't be here next year, but you'll have Ms. Goff. I've heard she's great. And just the ISM program, the experiences that you can have are incredible. As you can tell, I love the program. I've had a great experience here with ISM and with Liberty. And this is kind of the last thing that I'll do this year. So thank you all for being here tonight and supporting me in this and throughout my ISM journey, and really throughout high school. It's been a great ride. Thank you all for being along with me. Thank you.